Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2015 second session first exercise. The title of this exercise is Determination of the focal length of a converging lens. The aim of this exercise is to determine the focal length f of a converging lens L. For this we place an object AB at a distance p from L. So here P represents the distance between the object and the lens, perpendicular at A to its optical axis. On the other side of the lens, we place a screen E parallel to AB at a distance P' from L. And P' here represents the distance between the lens and the screen E. We adjust the values of P and P' in such a way that the image A' B' of AB is formed sharply on E. So here the image is being collected on the screen, and AB is equal to A' B'. Because the image is being collected on the screen, then the distance P' represents the distance between the lens and the image A', B'. So number 1, they are telling me specify the nature of the image A', B'. Notice that till this moment they didn't mention anything about this figure, so I'm not allowed to use it at all. So all of my answers must be restricted to the given text or to the previous parts. So they are telling me specify the nature of the image A', B'. Notice that here they told me that the image A', B' is formed sharply on E, and we know that only a real image can be collected on a screen. So let's write down, since it is collected on the screen, then in this case then the image A', B' is real. And now in number 2 they are telling me deduce that the image A', B' is inverted with respect to AB. Deduce means that I need to use the part just previously before, and in part 1 we have proved that the image A', B' is real, and we know that whenever the image is real it is inverted with respect to the object AB. So let's say that since it is real, then the image A', B' is inverted with respect to the object AB. And now in number 3 they are telling me the figure below shows AB. They mentioned the figure, so now I can use the figure. The figure below shows AB, A', B', the screen E, and the optical axis X' X of the lens L. So part A, redraw with the same scale the above figure. Okay, so notice that here the direction of propagation of light is not indicated, but from the positive direction of the x-axis we can know that the direction of propagation of light is from left to right. So this is the direction of propagation of light, and whenever we need to redraw we always start by drawing the optical axis at the middle. This is the optical axis having the same direction of propagation of light, which is from left to right. Now here the point A is located on the optical axis, so this is the point A, and the point B is located one division above A. A hat is found on B. Now let's trace the object AB. Moreover, the screen E is located away from AB by 1, 2, 3, 4, 5, 6, 7, 8 divisions. So 1, 2, 3, 4, 5, 6, 7, 8. And the screen is perpendicular to the optical axis. And the point A prime represents the intersection between the optical axis and the screen E. And the point B prime is located one division below A prime. A hat is found on B prime. Now let's trace the image A prime, B prime. Moreover, the scale along the x-axis is given by 15 centimeters. So this is it for part A. Hope we didn't forget anything. Now in part B, they are telling me determine graphically the position of the optical center O of L and represent L on the figure. So the word here determine means that we need to trace and justify at the same time. So first let's trace the optical center. Notice that here in the figure we have the object AB and the image A prime, B prime. So if we join B and B prime, the intersection of BB prime with the optical axis is the optical center O, because we know that an incident ray issued from B passing through the optical center emerges without deviation. Then let's write down the justification. Join B and B prime. The intersection of BB prime with the optical axis is the optical center. Because we know that an incident ray issued from B passing through the optical center emerges without deviation. Moreover, in the same part they are telling me represent L on the figure. We know that the lens L is perpendicular to the optical axis at the optical center O. So let's replace the lens L using the correct symbol of a converging lens, which is given by this. So done for part B. Now in part C, they are telling me trace the emergent ray corresponding to a luminous ray issued from B and parallel to the optical axis. And the word trace means that we only need to draw, no need to justify. The emergent ray corresponding to a luminous ray issued from B, which is parallel to the optical axis. Then let's consider a ray which is issued from B and parallel to the optical axis. And we don't forget arrows on light rays that indicate the direction of propagation of light. So we know that this ray will emerge passing through the image focus, but in this case we don't know the position of the image focus. However, we know the image B prime of B, and we know that all rays issued from B emerges from the lens going to B prime. So done for part C. Now in part D they are telling me this emergent ray meets the optical axis at a particular point M. So this is the emergent ray and this is the optical axis. This is the meeting point or the intersection point of the emergent ray with the optical axis. So this point is M. They are telling me what does M represent for the lens L. We know that an incident ray issued from B parallel to the optical axis emerges passing through the image focus. Therefore, the point M represents the image focus of the lens L. So now let's justify. Then the image focus M is the intersection of the emergent ray with the optical axis. Okay. Now in part E they are telling me determine graphically P and P prime. So P represent the distance between the object and the object lens. So we need to determine graphically the distance between the object and the lens. Therefore let's write distance between AB and L This distance is denoted by P, and it consists of 1, 2, 3, 4 divisions, and we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give me 60. Because the scale is in centimeters, then the value of P will be in centimeters. Always, all quantities in physics must have a unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. And now also they are telling me P prime. P prime represents the distance between the lens and the image A prime, B prime. So distance between L and A prime, B prime. Now P prime, the distance is denoted by P prime. It consists of 1, 2, 3, 4 divisions. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. And this will give me 60. Because the scale is in centimeters, then the value of P prime will be in centimeters. Therefore, P prime is equal to 60 centimeters. And now in part F they are telling me compare P and P prime. The value of P from part E is given by 60 centimeters, and the value of P prime is given by 60 centimeters as well. And whenever they tell me compare, we need to say that if they are equal, or one larger than the other, or less than. So in this case, P is equal to P prime. Then the comparison is given by that P is equal to P prime. And in the same part, they are telling me deduce the relation between P and F. So whenever the distance object lens is equal to the distance lens image, since P is equal to P prime, we know that the following relation holds, which is given by that P is equal to the double of the focal length F. Okay, so this is the relation. And now in part G they are telling me deduce the value of F. The word deduce means that I need to use the part just previously before, which is part F, and in part F we have proved that P is equal to 2F. And we know that the value of P is given by 60 centimeters. Therefore, if we divide both sides by 2, we will get that the focal length is equal to P divided by 2, and the value of P is given by 60. Therefore, F is equal to 30. Since P is in centimeters, then the value of F will be in centimeters. So F is equal to 30 centimeters. So the focal length of this lens is positive, which confirms or verifies that the used lens L is a converging lens, because we know that for a converging lens the focal length is always positive. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.